Hello everyone. In this part 4th of applications of derivatives, in the topic of tangents and normals, I'll explain angle of intersection of curves. So let's start with this point. Let us suppose in this figure we have a curve C1 whose tangent is this having slope m1. This is the curve C2 whose tangent is this having slope m2, and these curves are intersecting at the point P. Then to find out the angle of intersections of two curves, it is sufficient to find out the angle between these two tangents. We are considering this angle is here theta. Now, how will we calculate this angle theta? By this rule, tan theta is equals to modulus of m1 minus m2 upon 1 plus m1 m2. And this is the important note. If the curves are orthogonal, then we can take m1 m2 is equals to minus 1. Or if we have to prove curves are orthogonal, then anyhow we will show that m1 m2 is equals to minus 1. Now let's start with these questions. In question number 1, find the angle of intersection of curves xy is equals to 6, x square y is equals to 12. Now we have this two equations. First of all, let theta be the angle between two curves. Theta be the angle between two curves. Now, first of all, we will find out the intersection point from equation 1 and 2. From equation 1 and 2, what we are getting? We are getting x square. What is the value of y? 6 upon x is equals to 12. It means x is equals to 2. From equation 1, y is equals to 3. Therefore, intersection point of two curves is, what is this? 2, 3 is 2, 3. Now, for first curve, we have xy is equals to 6. Differentiate with respect to x. Once you will do the differentiation with respect to x, but we will get x as it is, y means dy by dx plus y as it is, x means 1, 0. It means dy by dx is equals to minus y upon x. Therefore, m1 is equals to dy by dx at 2, 3. It means what this become? Minus 3 by 2. Now, for second curve, we have x square y is equals to 12. Differentiate with respect to x square dy by dx plus y 2x is equals to 0. It means dy by dx is equals to minus 2y upon x. It means m2 is equals to dy by dx at 2, 3. It means what this become? This become, substitute the value of this. It means this become minus 3. Now tan theta is equals to modulus of m1 minus m2 upon 1 plus m1 m2. What is this m1? m1 is minus 3 by 2. And what is this m2? Plus 3. It means 1 plus minus 3 by 2. And what is this? Minus 3. And once we will do the calculation, we will get tan theta is equals to modulus of 3 upon 11. It means theta is equals to tan inverse 3 upon 11. And this will be the answer. Now let's start with this question number 2. Now in this question number 2, show that the curves cut at right angles. So let us suppose this is the equation number 1, this is the equation number 2, and let point of intersection of two curves, be x1 by 1, of two curves be x1 by 1. So once we are considering this thing, now first of all, for first curve, differentiate with respect to x. It means this become, now x cube means 3x square minus 3, x as it is, y square means 2y dy by dx, and then plus y square as it is. What is the differentiation of x? 1 only. Differentiation of 2 is 0. It means this is 0 only. Now this become 3x square minus, what is this? 3 to just 6x y dy by dx, and this is minus 3y square is equals to 0. It means minus 6xy dy by dx is equals to what this become? This become 3y square minus 3x square. It means you can say dy by dx is equals to y square minus x square upon what is this? Minus 2y 2xy. It means dy by dx at x1 y1 is equals to minus, this is y1 square minus x1 square upon 2x1 y1. So this is the m1. You can say this is equals to m1. Now for second curve, we have 3x square y minus y cube is equals to 2. Differentiate with respect to x. It means x square dy by dx plus, this is when we will do this thing, plus y x square means 2x minus 3y square dy by dx is equals to 0. It means 6x square, sorry, this 3x square dy by dx plus 6xy minus 3y square dy by dx is equals to 0. It means 3x square minus 3y square dy by dx is equals to, what is this? Minus 6xy. Take the minus 3 common from here. It means what this become? 3y square, sorry, y square minus x square dy by dx. And what is this? 2xy. This is 2xy. Now m2 is equals to dy by dx at x1 y1 at x1 y1. And what this become? This is coming, what is this? 2x1 y1 y1 square minus x1 square. Now we are observing m1 m2 is equals to minus 1. Therefore you can say that the curves are orthogonal. Therefore the curves cut at right angle. Look at this thing, because in this part we have to prove that this thing, that the cut at right angles. So we are directly not finding the points. We are just considering the intersection points are x1 and y1, and by calculation automatically it is providing minus 1. So this is the another way that without finding the points of intersections, we can just assuming this thing, and on the basis of this thing we will get m1 m2 is equals to minus 1. But this logic we can apply only in that case if we have to prove that they cut at right angles. Now let's start with this question number 3rd. Now in this question number 3rd, show that the curves x is equals to y square and xy is equals to k cut at right angles if 8k square is equals to 1. It means we have to prove that 8k square is equals to, if 8k square is equals to 1, then cut at right angles. So for this, these two equations are there. First of all, solve this for intersection points. It means from equation 1 and 2, from equation 1 and equation 2. Now what we will do, look at this thing, x, substitute the value of x, y square into y is equals to k. It implies that y is equals to k raised to power 1 by 3. Now from equation 1, x is equals to, we have y square. It implies that x is equals to k raised to power 2 by 3. Therefore intersection point B. What will be the intersection point? K raised to power 2 by 3 and k raised to power 1 by 3. Now for first curve, we have x is equals to y square. It implies that differentiate with respect to x, 1 is equals to 2y dy by dx. It means what this become, dy by dx is equals to 1 upon 2y. It means m1 is equals to dy by dx at which point? At the point k raised to power 2 by 3 and k raised to power 1 by 3. So what this become? m1 is equals to 1 upon 2 k raised to power 1 by 3. This is the equation number 1. Now for second curve we have xy is equals to k. Differentiate with respect to x as it is dy by dx plus y as it is. What is this? X is 1, it means 0. It means dy by dx is equals to minus y upon x. It means m2 is equals to dy by dx at which point k raised to power 2 by 3 and k raised to power 1 by 3. Now this become minus k raised to power 1 by 3 and this is k raised to power 2 by 3. Now in this question we have to show that if the curves intersect at right angles, then 8k square is equals to 1. First of all we will take let for orthogonal curves we have m1 m2 is equals to, so we are taking m1 m2 is equals to minus 1 and we will show this condition. Now what is this? m1 we have 1 upon 2 k raised to power 1 by 3 and what is this? m1 minus k raised to power 1 by 3 k raised to power 2 by 3 is equals to minus 1. Minus minus cancel out, this cancel out. It means 1 upon, or you can say 1 is equals to 2 into k raised to power 2 by 3, cubing both sides. It means 1 is equals to 8k square and this is the answer. 8k square is equals to 1. Now on the basis of this explanation you have to try other questions also, and don't forget to give the answer of this question in comment box. Thanks and God bless you.